Hello everyone. So today we are going to talk about this problem. It's a very famous problem, okay, and it's quite got a good number of likes, okay, out of about 10,000. So you can see we are talking about this. So let us read the description. So given an array, okay, nums with n object colored red, white, or blue, okay, sort them in place so that the objects of the same color are adjacent, okay, with the same color, okay. So the colors are red, okay, which is nothing but 0, white is 1, and blue is 2. We will use an integer like this to represent these numbers. You can solve the problem without using any library sort functions, okay. So I given this nums of this one. Example is this one, 0 0 1 1 2 2. Okay, so this is just how you need to do this, okay, and we need to do without using sort function, okay. And another example is this 201, which is 012, okay, like this. 0 should come before, then 1 should come, and then 2 should come, and with the group, okay, every group will be different, okay. Constants are that now n will always be equals to nums dot length, okay, and n can vary from 1 to 300. Nums of either can be 0 1 or 2. Only 3 possibilities are there. So could you try to come up with a one pass solution using only extra constant extra space, okay. So they are given that you can use extra space, but you need to do in one pass, okay. If it is having first let us do try to use brute force solution, which is nothing but running the library function which they have didn't allow, okay. So it is order of n log n complexity. We just gives sort this nums of length nums, okay, and just return that, okay, but that is not allowed. Another approach can be just keep the track of zeros, ones, and twos. Just run a for loop, make 3 variables for 0, for 1, for 2. Every time you run you loop once, just check what this value, this is values 2, so increase the 2's counter, then we will having 0, then increase 0 counter, then 1 counter. So at the end of this for loop we will be having 2 for everything, okay. 0 will be 2, 1 will be 2, 1's count will be 2, and 2's count will be 2. And then make an empty array, okay. Put all the values here. First put the zeros, second ones, and then twos, okay. Just do that, and once done just return that, okay. So that can be that, but that is 2 pass solutions, okay, and we are using extra space also there, okay. Another approach, another way we are going to be discussing, that is quite intuitive. Let us jump into the whiteboard and discuss the solution there. So let us try to understand, okay. So here we are going to be having 3 pointers, okay, L, M, and H, okay. We can call as low, high, and medium, okay. So initially we'll be running this loop till medium is less than equals to height, or medium is less than equals to high, okay. So in this we are having this medium and low at the index 0 starting. Now we'll be every time doing the comparison with M and the value, okay. If the value is having the value of 2, initially you can see we have 2. So what we are going to be doing, if it is 2, then we'll be swapping it with the high value, okay. So let us swap this, okay. So once we have swapped, the values will be something like this: 0 0 2 1 1, and this value will become 2. Once we have done that, we will be moving this high pointer from here to here, okay. So high is at this position now, this position. Now again this L and M are not moved from here because new value has arrived, which is 0. Now again this value will be compared. Now M is 0. So in case of 0, we are going to be incrementing our L and medium by 1 positions. So L and M are both of them moved 1 position. Now again 0 is there, M is 0, so again this both will be incremented. So basically one swapping is also there, but for now it doesn't make any changes. So what is the swapping? Swapping is between L and M only, okay. If the value of the mid, which is M, is 0, in that case we'll be swapping it with the low value. but low in this case is same only, so that's why it doesn't make any difference. So now again this value L and M are M is 0, so in this case L and M are move again here, so it reached here. Now at this position 2 is there, so in this case we are going to be swapping it with the high value. So high is this position, so swapping is done here. So after swapping, the values will be something like this. 1 will come here, 1 will be here, 2 will be here, and 2 will be here. High is been increment moved to this position now, and L and M, once we have done, it will be remaining here only now because new value have arrived. Now again M is the compared with the value 1, M is equals to 1, which means we are going to be incrementing our M value, not L value. So whenever we have M equals to 2, we'll be swapping with the high value, decrementing our H minus minus. Okay, if our M value is 0, okay, like this, if M value is 0, this is case 1, this is case 2. So when M is equals to 0, in that case we'll be swapping with the left value and the mid value, incrementing our L and M, both values. If our M is equals to 1, in that case we will only be incrementing our M. Okay, so M has been incremented, so once we have incremented, it will reach here. Okay, now again M is 1, it will be incremented here. So now the condition of which is nothing but M, we will be running this M is greater than equals to at till this position only. Now this condition has become false, so in that case we'll stop, and you can see we have successfully separated the value 0 0 1 1 and 2 2 will be returned here. Okay, so I hope this explanation you have got. Okay, let us take another example and understand it better. Now let us try to do this. Okay, we have 2 1 1 0 0 1 2. Okay, L and M are here only, so you can see L and M, first M is 2, so it will be swapped with the high value. So after swapping, it becomes something like this only, similar to that. High will be moved here, so high is at this position. Now L and M will be again compared, it is 2 only, so it will be swapped with this value. So after swapping it, this value becomes something like this. I'm moving fast. Okay, now again H will be moved one position ahead, so it will be here at this position. Now again L and M will be not moved because new value has arrived, so now this time it is value is 1. Okay, now whenever we have one value, we'll be incrementing our M value. So L will be here only and M will be moved here. Again H is at this position only. Okay, and again M will be moved from here to here. Okay, L is at this position only. Now again M will be moved from here to here. Now M is at this position of 0. Now whenever we have 0, we'll be swapping it the value L. Okay, swapping it with L becomes something like this, and we'll be incrementing our L. L comes at this position, and this position is 1, basically 0 at this high, 2 2. Okay, now again M is at this position, right? Yes, because we are moving M here, M is at this position because we are moving L and M both whenever we are getting value 0. Okay, so now again M is 0 here in this case, so if it is 0, we are going to be comparing it with swapping it with value L. So this value becomes something like this, and M has been moved from here. It was here, so it has been moved here. Now the condition which was M is greater than equals to this becomes false, and we are stopped, and you can see we have successfully done the part. Okay, so that was the explanation part. Let us try to write the code for this. Let us write the code for that problem. Okay, so we have int low, which is at 0 index, int M, which is at again 0 index. We'll be having high, okay, which is nothing but at nums dot length minus 1, last index, nums dot length minus 1 minus 1. Now we'll be running our loop, okay, while M is less than equals to height. Okay, now we need to check every time the value of M. So if our m, first let us check for the value 0. If the value is 0, so in that case what we need to do, we need to swap it with the left one, right? So int temp equals to nums of L, nums of L becomes nums of M, okay, and nums of M becomes temp, okay. And once we have done that, we need to increment our L also and our M also. So this part we already discussed. Now else if our M is 1, if our M is 1, so in that case we just need to do M plus plus, okay. In else part, what we need to do, that is 2 only, so in that case we need to swap it with the last one. So in temp equals to nums of H, okay, nums of H equals to nums of M, and nums of M is nothing but temp, okay. So this is done now. And yeah, one more thing, here we need to decrease the H also, right? And the M remains the same only. We're not going to be updating anything other than that, okay. So I think that's it for this. Let us try to run the code. I hope it works. Non-cut, please try. So we missed one part actually. Here it should be in nums of mid, okay, nums of M, because we need to take that value, right? So nums of M again here. Else part we don't need to do anything. Still doesn't working. Then let's do this thing. Actually I need to be here only, and this was correct only. So let us see again. See, our left pointer is at 0, our medium pointer is also 0, okay. Left is nothing but low pointer, and this is high pointer which is at the last index. We are running when our M is less than equals to high. We are comparing if our value of nums of M, okay, is 0, in that case we are swapping with the left one or low one, and we are incrementing our left, we are incrementing our medium, correct? If our M is 1, we are incrementing our M pointer. Else part we are doing this operation, which is swapping with the high and reducing the high by 1. Yeah, there is some issues with the server, but it is working fine, okay. So that's it for this video. Again it is not working, but yeah, the code is working fine. I hope you got the explanation part, okay. So that's it for this video. We'll meet in the next video.